The nuclear force is the force between two or more nucleons. It is responsible for binding of protons and neutrons into atomic nuclei. Sometimes the nuclear force is called the residual strong force, in contrast to the strong interactions which are now understood to arise from quantum chromodynamics. Here is a Feynman diagram of a strong proton-neutron interaction mediated by a neutral pion. Time proceeds from left to right. Here is a picture of a diagram with the individual quark constituents shown to illustrate how the fundamental strong interaction gives rise to the nuclear force. Straight lines are quarks, while multicolored loops are gluons. The carriers of the fundamental force, other gluons which bind together the proton, neutron, and pion, are not shown. Nuclear energy is energy due to splitting or fusing of atomic nuclei. Nuclear energy is released by three exothermic processes: radioactive decay, where a neutron or proton in the radioactive nucleus decay spontaneously by emitting either particles, electromagnetic radiation, gamma rays, neutrinos, or all of them. Fusion, two atomic nuclei fuse together to form a heavier nucleus. Fission, the breaking of a heavy nucleus into two, more rarely three, lighter nuclei. Nuclear energy was first discovered by French physicist Henri Becquerel in 1896, when he found that photographic plates stored in the dark nuclear uranium were black like X-ray plates, which had been just recently discovered at the time 1895. Nuclear chemistry can be used as a form of alchemy to turn lead into gold or change any atom to any other atom. Radionuclide production often involves irradiation of another isotope, with alpha particles, beta particles, or gamma rays. Iron has the highest binding energy per nucleon of any atom. If an atom of lower average binding energy is changed into an atom of higher average binding energy is given off. The chart shows that fusion of hydrogen, the combination to form heavier atoms, releases energy, as does fission of uranium, the breaking up of a larger nucleus into smaller parts. In physics, mass-energy equivalence is the concept that any mass has associated energy and vice versa. In special relativity, this relationship is expressed using the mass-energy equivalence formula: E equals energy, m equals mass, c equals the speed of light in a vacuum. The formula was derived by Albert Einstein. In the formula, C2 is a conversion factor required to convert from units of mass to units of energy. The formula does not depend on a specific system of units. In the international systems of units, the unit for energy is a joule, for mass, the kilogram, and for speed, meters per second. Here is an example of E equals mc squared. The energy of the colliding proton and antiproton is transformed into the masses of the much more massive top and anti-top quarks.